Welcome back to the Docker series. Lesson 4, and this is the one where we stop treating containers like permanent things. Here's the core idea. A container is a soap bubble. Pop it, and everything inside is gone. That's perfectly fine for an Nginx serving static HTML. It's catastrophic for a postgres holding your customer data. Volumes are the bridge. They let the app stay throwaway while the data stays precious. So here's the map for the next 30 minutes. 4 skills. First, why containers lose data in the first place. The writable layer dies with the container, full stop. Second, the 3 mount types you have to choose between: bind mounts, named volumes, and tmpfs. Third, the CLI verbs to manage them: create, ls, inspect, rm, prune. And fourth, the persistence pattern you'll actually use in production for Postgres, Redis, MySQL. Learn it once, apply it everywhere. Skill 1, why data dies. Picture the container as a soap bubble. Pretty, useful, and gone the instant you pop it. Watch the sequence on the left. Spin up Postgres, create a customers table, insert some rows, remove the container, start a fresh one. Run /DT and nothing. No relations. Your table is gone, forever. The rule is simple. A container is a process, and a process is ephemeral. When it dies, the writable layer goes with it. Volumes exist precisely because data needs to live outside the bubble. So how do we keep data alive? Docker gives you 3 mount types, and each one answers a different question. Bind mounts hook a folder on your laptop straight into the container. Perfect for live editing code, terrible for production. Named volumes are Docker's own managed storage. Boring, reliable, exactly what you want for a Postgres data directory. And tmpfs lives in RAM and vanishes with the container. Ideal for secrets and session tokens you actively don't want lingering on disk. Here's the rule that covers 90% of your decisions. Bind mounts for code, named volumes for data. Inside the container, they look identical. Same path, same files. The difference is on the host. A bind mount lives at a path you pick, in your project folder, edited like any normal file. That's why it's perfect for code in development. A named volume lives in Docker's own directory, hidden behind root permissions, backed up with Docker run and tar. Boring, locked down, and exactly what your Postgres data needs in production. Now let's actually drive these things. 5 commands, and if you've used Docker image or Docker container, you already know the shape. Create makes an empty named volume. List shows you everything Docker is holding onto. Inspect tells you exactly where it lives on disk, handy when you need to back it up. Remove deletes 1, but only if nothing's mounting it. And prune is the nuclear option. Every unused volume, gone. Be careful with that last one in production. Here's the pattern worth memorizing, because it's identical across every database you'll ever run. Named volume, mounted at whatever path the database writes to. For Postgres, that's var lib postgres kl data. For MySQL, it's var lib MySQL. Redis uses data, Mongo uses data db. That's the whole trick. Watch what happens. We create a table, insert a row, then forcibly delete the container with rmf. Start a fresh container pointing at the same volume, and the data is right there waiting. The container was disposable. The volume wasn't. Once that pattern clicks, here are 6 moves worth keeping in your back pocket. Append :ro for a read-only mount when the container should look but never touch. Same trick for shipping Nginx configs from the host. Pipe a tar stream out of an Alpine container to back a volume up to a single file. Label volumes at creation time so you can filter prod from dev later. Use volumes from to chain mounts between containers. And when you need the actual host path, Docker volume inspect with a Go template hands it to you directly. And here's the whole lesson on one page. 12 patterns covering everything you'll actually reach for. Bind mounts, named volumes, read-only flags, tmpfs for RAM, the verbose, mount syntax, and the 4 management verbs, create, ls, inspect, prune. Screenshot it, pin it next to your terminal. One note on the bottom left of the middle column. Docker volume RM is listed as must not be used, meaning never run it against a volume holding data you care about. Prune with intent. Speaking of mistakes, these are the 5 that have bitten thousands of juniors. Number 1, running a database container with no volume at all. 1 Docker RMF and your data is vapor. Number 2 is sneaky. You mount a volume, but to the wrong path. Postgres keeps writing, just to the writable layer, and you don't notice until the container is gone. 3. Docker volume prune during maintenance. Unused just means no running container, so a stopped DB is fair game. 4. Mounting over directories that already had files in the image. Your mount hides them. And 5. The Linux classic, UID mismatches. Container runs as 1000, your host folder is owned by 501, permission denied. Chown it or just use a named volume. Enough theory. Time to put your hands on the keyboard. 3 exercises. First, mount a folder into nginx and edit the HTML live, no restart. Second, the proof. Run Postgres on a named volume. Insert a row, force remove the container, start a new one, and watch your row come back from the dead. Third, learn the housekeeping. Volume else, inspect the mount point, then clean it up. Do all 3, and volumes will stop being theory. And that's lesson 4. You now know the 3 mount types. You can drive the volume CLI, you've seen the database pattern that saves real-world data, and you know how to back it up. Your data is safe, but a database alone isn't an application. It needs a web server to talk to it, an API to query it. So next up, networking. Containers talking to containers found by name. See you in lesson 5.